The anhydrite-bound, self-leveling floor screed, labor and environment friendly. Floor screed are intermediate layers that fulfill the role of offering a flat surface on an otherwise rough, load-bearing floor. They offer a flat surface for the application of any final floor covering. Over recent years, these finishing layers, usually between 3 and 5 centimeters thick, have increasingly been made of anhydrite-bound material. The screeds are made with liquid mortar, which is poured onto the construction floor with the aid of pumps. Anhydrite, a water-free gypsum, demonstrates excellent stability of form when used as a binder in mortar. In this film, we discuss the development of the increasingly popular anhydrite on the basis of FGD gypsum, and we demonstrate how self-leveling floor screed are applied. Firstly, however, let us present some of the more important arguments for the use of self-leveling floor screeds. Rough construction floors are still often finished with a cement-bound screed surface. To do this, a laborer may have to shovel 20 tons of sand in a day. He would then add 6 tons of cement and 2 tons of water. All this entails enormous physical effort. The traditional floor layer normally performs his work on his knees, whatever the weather conditions. This constantly places huge stresses on his knees, arms and back. Due to these unfriendly conditions, traditional floor layers demonstrate very high absenteeism, which in many cases may be the precursor to full disability. In practice, only small numbers of these floor layers reach their pension. With the application of self-leveling floor screeds, this excessive physical labor can be a thing of the past. The mortar used is fluid and therefore largely self-leveling. It takes next to no effort to apply and finish the mortar. Pumping teams can now easily achieve 1,000 to 1,500 square meters a day. This is 4 to 5 times higher than with the regular sand cement floors. Work is done in an upright position, dramatically reducing stress and burden on knees, arms and back. Statistics show that absenteeism drops accordingly. Anhydrite, prepared from flue gas desulfurization gypsum, today represents an excellent alternative to synthetic anhydrite, released from the preparation of hydrogen fluoride. The FGD gypsum is formed in the cleaning of flue gases from coal-fired power stations. The aim of the decontamination is the prevention of further acidification of the environment. To this effect, the power station's flue gases pass through a so-called scrubbing process in the flue gas desulfurization installation. During the process, sulfur dioxide is converted into a wet gypsum slurry via a chemical reaction involving a limestone slurry. After thickening and removal of water, a moist gypsum is left, which serves as a raw material in the anhydrite production. Before the anhydrite binder can be used in floor screeds, the chemically bound crystal water needs to be removed from the wet gypsum. This is done to facilitate the reaction with water during the hardening process. To this effect, the material undergoes calcination. Here, the gypsum is brought into a counter stream of hot air at 800 degrees. This temperature is produced by two enormous gas burners in the center of the production unit. After cooling down and grinding, the anhydrite is then ready for use as raw material. In order to achieve the required characteristics, a mixture of additives may be added to the anhydrite. Continual quality control ensures that the anhydrite binder meets all the demands placed upon it. It is then transported by bulk truck to the various customers. Screed mortar production uses anhydrite binder as well as sand and water. Screed mortar preparation at the construction site is performed with compartmentalized silos or mobile mixing units. During preparation at a mortar plant, the raw materials are mixed together. The mortar producers supply their product ready for use according to the required quality specifications by truck mixer at the construction site. This means a constant quality can be maintained. In contrast to applied floors, quality control can be performed easily. To check the strength of the resulting floor, test prisms are regularly verified for flexural and compressive strength. Before pouring, the underlying surface and working area need to be prepared. In order to achieve a high-quality floor screed as well as to optimize working conditions, it is necessary to make the area wind and watertight. When pumping directly onto the load-bearing floor, slight moistening of the underlying surface is usually sufficient as a pre-treatment. Only when extra demands are placed on the floor with regards to adhesion to the underlying surface, for example with layers thinner than 20 mm, should the load-bearing surface be pre-treated with a bonding primer. The load-bearing surface should always be properly cleaned beforehand. As the pumped mortar is very liquid, mortar runoff should be avoided. Pipes in the floors should be properly fastened to the base in order to avoid lifting. The level datums should be clearly displayed by the contractor in every area. The pumping team uses these to establish the precise height of the floor screed. There must be sufficient room to position the truck mixer, silo or mixing unit at the construction site, as well as the mobile pumping unit. The information on the delivery ticket from the mortar plant is checked by the foreman at delivery. The flow is measured before pouring as part of quality control. This gives an indication of the workability and water content, which in turn influence the final strength of the floor. Anhydrite floor screed are suitable for dry areas in almost all buildings and can be used for new construction or in renovation works. Thickness may vary from 2 to 10 centimeters depending on the finish and wishes of the customer. Applying the mortar to the floor is simple and takes place by means of a pump and a flexible hose. A floating straight edge is used to remove possible entrapped bubbles and to give the final flat surface. The correct height can be measured by means of a combination of a laser and a receiver, which indicate that the required floor height has been reached by producing sound signals. The temperature in the working area should be between 5 and 30 degrees Celsius at all times. Depending on the conditions, the time needed for hardening of the anhydrite is usually between 48 and 72 hours. No access should be allowed to the area during this period. After that, further construction work can continue. Floor screed can be applied directly to the load-bearing surface or on an insulating layer as a floating floor screed. Anhydrite demonstrates minimal shrinking and is highly fire-resistant. The high strength is a result of the material's high density. This high density also has a beneficial effect on sound insulation, particularly when the floating floor screed version is used. The anhydrite floor is normally covered before it is taken into use. This can be done by means of hard or soft materials such as carpets, tiles and vinyl, etc. This may not, however, be done before the area can be heated. Before gluing the floor covering to the screed, the carbonate skin, which forms on the surface of the screed, should be removed by means of brushing or sanding. This is done to facilitate the screed's drying process and to allow adhesion of the floor covering. After this, the floor screed always should be made dust-free. Depending on the type of floor covering, different humidity demands are placed on the floor screed when applying the floor covering. It is particularly important to have a dry screed when applying impermeable floor coverings. In order to determine the moisture content, the floor's humidity should be measured beforehand. These days, anhydrite-bound floor screeds represent an integral component of modern construction practice in which labor conditions are very important. The use of self-leveling floor screeds considerably reduces the physical work. The application of FGD anhydrite means industrial byproducts can be used effectively and gives the availability of very pure anhydrite of a consistent quality. The health and environmental aspects have been thoroughly investigated internationally, and these investigations show there are no barriers to the application of anhydrite. Together with sand, water and additives, this binding agent represents the key to the self-leveling floor screed's remarkable success.